Lecture will be about oxidation state or oxidation number. In this lecture, we will discuss about the rules that is used for assigning the oxidation state. The oxidation state or oxidation number is the apparent charge, positive or negative, which an atom would have in a molecule or ion. Sodium chloride is taken as an example. Sodium has plus charge and chloride has minus charge. So plus 1 and minus 1 are the oxidation state of sodium and chloride respectively. Rules for assigning the oxidation number. First rule is the oxidation number of free element is 0. For example, hydrogen, oxygen, iodine gas that are freely present, that are present in nature, their oxidation state is equal to 0. There are metals, manganese, copper, zinc, and many more metals that are present in a free state, their oxidation number is 0. The oxidation number of hydrogen in its compound is plus 1, but in metal hydride it is minus 1. Now in case of plus 1, we will take the example of sulfuric acid H2SO4. So in this case the hydrogen has plus 1. Each hydrogen has plus 1. So there are 2 hydrogen. So in sulfuric acid hydrogen has plus 2. But each hydrogen has plus 1 charge. In case of minus 2 metal hydrides, sodium hydride, sodium has plus 1. So in order to balance this plus 1, we will take minus 1. So in this case, the hydrogen has minus 1. Magnesium has plus 2. So in order to balance it, it has minus 2. So each hydrogen has minus 1 charge. The oxidation number of oxygen in its compound is minus 2, but in peroxide and superoxide it is minus 1 and minus half respectively. So normal oxide in which oxygen has minus 2 charge, we will take the example of sodium oxide, and even we will take the example of water. Sodium belongs to the first group, so it will have plus 1. Now there are 2 sodium present, so we will put plus 2 over these 2 sodium. In order to balance it, we will put minus 2 over oxygen. So in case of normal oxide, oxygen has minus 2 oxidation number. In case of water, now hydrogen has plus 1 oxidation number. So there are 2 hydrogen present, so we will put plus 2 over there. In order to balance it, we will put minus 2 over oxygen. In case of peroxide, in which oxygen has minus 1 oxidation number, we will take the example of sodium peroxide and hydrogen peroxide. Sodium peroxide may be written as NaO. Sodium belongs to the first group, so we will put plus 1 over there. As in order to balance it, so we will put minus 1 over oxygen. So in case of peroxide, oxygen has minus 1 oxidation number. In case of hydrogen peroxide, first we will simplify the formula. 2 and 2 will cancel out. We will get HO. Now hydrogen has plus 1. In order to balance it, we will put minus 1 over oxygen. So in case of hydrogen peroxide, oxygen has minus 1 oxidation number. In case of superoxide, in which oxygen has minus half oxidation number, we will take the example of potassium superoxide. So potassium belongs to the first group, so it will have plus 1. In order to balance it, we will put minus 1 over these 2 oxygen. Now there are 2 oxygen, so we will have minus half for each oxygen. So minus 1 is for 2 oxygen, and each single oxygen will have minus half, and minus half will produce minus 1. There are some compounds that are when oxygen combined with fluorine. In this case, the oxygen has plus 2 oxidation number. It means that fluorine is more electronegative than oxygen. So oxygen will be in positive oxidation state when it will combine with fluorine. So here oxygen will have +2 oxidation number. The oxidation number of element of group 1, 2 and 3 in the compounds are +1, +2 and +3 respectively. So the first group are lithium, sodium, potassium, rubidium, cesium and francium. Second group beryllium, magnesium, calcium, etc. And third group members are boron, aluminium, gallium, indium, etc. So when these elements are present in some compounds, they will have +1, +2 and +3 oxidation numbers. In case of 1A, we will take the example of sodium chloride. So sodium will have +1, that is balanced with -1 of chloride. In case of second A, 2A, these metals, magnesium chloride is taken as example. So magnesium has +2 and each chloride has -1. So there are two -2. So we will put -2 over there. -2 is balanced with +2. So magnesium has +2 in magnesium chloride. In case of third A elements, aluminium chloride is taken as an example. Aluminium will have +3, that is balanced with 3 chloride that each have -1. The oxidation number of the halogen in of 7A group of the binary compound is -1. Now the halogens include fluorine, chlorine, bromine, iodine, etc. They will have -1. So we will take the previous example, sodium chloride. Here the chloride has -1. Here the chloride has -1. But we will put -2 over there because there are two chloride, but each chloride has -1. Here we will put -3 over these Cl3. There are 3 chlorides and each has -1. So the oxidation number of halogen of group 7A in their compounds will have -1 oxidation number. The algebraic sum of the oxidation number of all atoms in a molecule is 0. We will take the example of potassium permanganate, potassium chromate and sulfuric acid. Now if there is no charge given over this compound or this compound and also over this compound, this means that the sum of all these charges will result 0. So potassium belongs to the first group, so we will put +1 over there. Oxygen has -2, so there are 4 oxygen present, so we will put -8 over there because 4 into 2 will result -8. Now we will put such a number that will result 0. So -8 and +1 or +7, if we sum up all these number, it will result 0. In case of potassium chromate, here potassium belong to the first group, so it will have +1, but there are 2 potassium present, so we will put +2 over there. Oxygen has -2, so there are 4 oxygen present, so -2 multiplied by 4 will result -8. So we will put a number that will result 0. So -8 +2 and +6, it will result 0. In case of sulfuric acid, hydrogen has +1 oxidation number, so there are 2 hydrogen present, so we will put +2 over there. In case of oxygen, here is also given O4, just like previous example, so we will put -8 over there. In order to make it 0, their sum is 0. -8 +6 and +2 will result 0. So sulfur will have +6. Here it will have +6, chromium and manganese will have +7. The algebraic sum of the oxidation number of all the atom in an ion is equal to the charge on that ion. We will take the example of sulfate that will have -2 charge and phosphate that will have -3. So we will solve it. Oxygen has -2, so there are 4 oxygen present, so it will result -8. We will put a number with -8 that will result -2. So -8, when we will combine it with +6, it will result -2, because there is a rule that their sum will be equal to the charge on that ion. In case of FpO4, so O4 oxygen has -2 and there are 4 oxygen present, so it will result -8. We will put a number with -8, so their sum will result -3. So here +5 is the suitable number that will result -3. -8 plus 5 will result -3. So the algebraic sum of the oxidation number of all the atom in an ion, this is the ion and this is the ion, is equal to the charge on that ion, that is -2 and -3, etc.